All right. So we're back in. Some people are still joining. Still joining. Right. So back to our work. This is where we started. This is the question we are solving here. This is the question. It says the table below shows the mileage and prices of 8 cars in a car mart. It's mileage and price, and they say construct a scatter plot. We did this in Excel before we left, before we were timed out. And this is the result that Excel gave us. From there, we copied the scatter plots and pasted it in that section. So that gave us, that I showed you a few minutes ago. And the second question says, calculate the correlation coefficient R. This is an R here, it's a small r. So again, when we pasted the result in Excel, like I explained in the previous lecture session, we got the result R for R, which is this here. And because the scatter plot is negative, shows a negative relationship, that means our R will be a negative value. So we have it here. All this I explained in the last session. Say R negative 0.76. I interpreted that it means that a strong negative linear relationship between the X variable and Y variable, where X is the mileage and Y is the car price. Next thing we need to calculate is the R squared, which is the coefficient of determination, R squared. So our R squared equals, so I'm gonna correct it now, R squared. Okay. Equals, from what we have, make this bigger. Make it 16. From our chart, our Excel result, our R squared is the it shows here in this spot. You can see right here, R squared. I'm gonna use this to show it, maybe a little blue. Okay, 0.574 or 0.57. So 0.57 rounded. So 0.57 is our R squared. 0.57 0.57. See, how do we explain this interpretation of this? These are the R squared the R square of this, okay, means that about 57%. Now, if you can, our R show that the price decreases as mileage decreases. So 57% of the change in car price is explained by this change in mileage. That's what it means. Any question for me on this? Does anybody have a? Yep. Okay. No. Okay. Good. Excellent. Okay. Now, the next question they ask is, what will be the predicted price for a car with a mileage of 45,000 miles? Solution. So to do that, we need the regression equation. It didn't ask us to compute the regression equation here. So we need the regression equation. Solution. Now, the regression equation, like I explained at the beginning, let me show you what it is. The model, how it looks like. It looks like this. Y equals to B0 plus B1x. That's how the regression equation is. Okay, so I'm gonna take it and press it there. So because before we can make prediction, we need the equation, the regression equation. So I'm gonna put it here. So what will be the predicted price for a car with for 5,000 miles? Now we need to figure out what B0 and B1 is. For 5,000 miles means that X equals 45. If we remove all these 3 zeros, like I did in the chart, the table, you can see that everything here is in thousands. This 16 means 16,000. 21.8 means 21,800. So 45,000 miles means just 45. So, but first of all, let us figure out what the slope estimates in this the regression equation. So we have it in this form. I'm going to show you what represents B. B0, my Excel output. This is our B0 right here. And this is our slope. Okay, that's our slope. So I'm gonna make it yellow. Okay, so let me write it down so we can now go and put them in the equation that we have. P0 equals 17.1. B1 equals negative 0.09. Okay, because the B0 is 17.10 for B0 and negative 0.09 for slope. Now, you can go and put it in to form our regression equation. So that means this one here is 17.10, and this is the slope, which is negative 0. So when you put them into this formula, you will see that the regression equation, becomes Y equals, so instead of writing B0 here, we're going to write 17.1, 17.10. Then for B1, we're going to use negative 0.09, negative 0.09. Okay, 0.09 x. So having found this equation, we can now predict the car price. So for 45,000 miles of a car that has a 45,000 miles, so that means our X is 45. So the price Y, the price Y will be 17.10 minus 0.09 times 45. And that will give us the amount we are looking for. So let me write this down so we can get it from the calculator. 17.10 minus 0.09 and 45. So I'm going to get it from the calculator. Now, to get it from the calculator, we need to find the calculator, download the calculator. And there's a free calculator you can use. It's called, okay, I think it's, we can get it from here. Desmos.com/scientific calculator. To bring it up, Hope you can see it. Can you see the screen? Hello?
Yes.
Okay, good. So we have 17.10 minus 0.09 times 45. That'll give us the 13.05. So I'm going to go and put it in at 13.05. 13.05, which means, what it means, 13,000. 050 dollars. So a car, the predicted price of a car that has 45,000 miles, the predicted price this way. The predicted price of a car for a car with 45,000 miles is, excuse me, is 13,050. See, very easy. So once you get the equation, you can now make prediction based on that equation. Any question on this? Any question? No question. Good. Now, the last question that says, is there a relationship between mileage and car price? And use alpha 0.05. So first of all, you state no hypothesis that the car price and mileage are not related. And the alternative is that they are related. So when we can now let's look at our result from the Excel if they are related. So you can see where we have our. This can actually help us get it, or we can use the p-value here. So now let's using the p-value. We have that our alpha. 1 minute. Okay, alpha is this 105. See decision criteria. Decision alpha is 0.05. Okay. Okay. Alpha is 0.05. Let's see what the p-value is. From Excel, we know that the p-value is right here. Can see p-value here. Highlight it. P-value. Can see p-value. So for the independent value, you can see right here. 0.02939. That's 0.029. I'll write it down. P-value. P-value 0.029. I'm going to write it. So our p-value p-value equals 0.029. 0.029. So what do we do? Are we going to reject HO or not? So if you remember how we make decision based on p-value, let me show you that criteria that we use. Okay, it says if the p-value is less than or equal to alpha, make sure I'm seeing this. Okay, good. Let me see. Make sure you're seeing it. So if the p-value is less than or equal to alpha, reject no hypothesis. If the p-value is greater than alpha, do not reject. So in our own case, we can see that what we have here is for our decision, this is alpha, this is p-value. P-value is less than alpha, so we reject. Reject HO as the null hypothesis, since the p-value of 0.029 is less than alpha. P-value is less than alpha. So when it's less than alpha, you reject. Okay, I'm gonna say there should be more characters. I see. Okay, less than alpha. Alpha of 0.05. So since p-value is less than alpha of 0.05, we reject HO. That means HO is not good. Okay. That means that H1 is the correct hypothesis. That's conclusion will be conclusion. Says the car price and mileage are linearly related. Any question on this? Any question, class?
No, not for me.
Okay. So this will be the end of the lecture. Like I said, this is our last lecture for the semester. Next week there won't be any lecture. Then the week after that, the final exam. For the final exam, I'm going to go by the calendar schedule provided by the college. So I'll post the probably by tomorrow. I'll post the announcement of the date final exam. Now let me take your attendance so you can leave. Any question before we leave?
No, that's good. Mr. Oji, do you know when the final exam is going to be? Like, is it going to be next week or the week of the 20th?
Yeah, that's what I'm saying. I'm going to go by the university calendar. I'll post the announcement tomorrow so you know when. Okay.
Do we have any assignments due this week?
You have your homework. Hold on, I don't have it off head. It's a class, I believe. Okay, I'll make it big. So you can, if you look at my announcement, you see I have two assignments: the project and the project is already past due, I think. But yeah. I just put it here just in case if you haven't done it, you can still do it and submit.
Okay.
Then homework 10. Homework 10 will be available tomorrow.
All right.
So let me call your name, sir. This is Steve, right?
Yeah, it's Steve.
Steve, okay. Letitia, you still there? Letitia, are you still there?
I'm here.
Okay, good. Then Mr. Carter.
Yes, sir.
I see you guys. Maybe I see you guys on this street. I'll say hello because this is our last class. Yeah.
I appreciate it. Thank you.
You're welcome.
All right. Have a good one.
You too. You have a good one. Okay, bye.
All right. Good one, sir.
Don't forget to say the email, okay?
What email?
No, I'm talking to Mr. Carter.
Oh.
Yeah.